Hello and welcome to Field Notes on Climate Change, the podcast from the front lines of Arctic research, based at the Abisko Scientific Research Station in northern Sweden and produced in partnership with the Climate Impacts Research Centre. I'm Emma, and in this episode I'm heading uphill once again, this time to find out what climate change and our warming annual temperatures are doing to the plant communities adapted to live at the very top of our mountains. Our mountains are shrinking, shout headlines referring to summits and climate change. And while that's not literally true, our mountains are staying pretty much the same shape and size. It's the alpine region, so the coldest part of the mountaintop, that's shrinking thanks to climate change. And what's happening to the plant communities that live on these summits is of great interest to plant ecologists. Are warmer adapted species able to move up the slope? Will they compete with our summit species? And are we going to lose our specially adapted species from this top? To find out more, I'm spending the day in the field with Bente Graae, a professor in plant ecology at the Norwegian University of Science and Technology, and Pieter de Frenne, a professor at the Forest and Nature Lab at Ghent University. So first things first, let's catch up with Bente.
My name is Bente Graae. I am working at Norwegian University of Science and Technology in Norway. I actually used to work also with the climate-related questions in Greenland. And so I was living 3 years in an Arctic station belonging to University of Copenhagen in Greenland. And after that, I worked in Abisko for 5 years. But now I'm back in Europe, and I am further south in Europe than Abisko. And I am working at this Norwegian university now as a professor in plant ecology.
So quite the Arctic expert then.
Well, I have been working many years with these kind of questions, yes.
Okay, well, I'm really looking forward to coming out and joining you and Peter tomorrow. I'll be getting up at the crack of dawn and meeting you at your field site. And we'll explain a little bit more about what we're doing when we actually get there. But just to give me a bit of a hint, I'm going to ask you one question now. Now, because climate change research is a term which really covers masses and masses of projects and loads of topics, what does climate change research actually look like to you in the team?
Yeah, we are just covering like a little piece of the whole picture. So we are plant ecologists. So what we are interested in is knowing how temperature and variation in temperature is affecting the vegetation cover, and also a little bit about the recruitment processes. How fast can vegetation change? How fast do plants move?
Great. Well, thank you very much. I will see you in the morning.
Good.
So broadly, what is it that you guys are looking at when you're up here in the Arctic?
What this whole project is about climate change and how the vegetation is going to change, or how it is changing when the climate is getting warmer. Because what you have on the mountaintops is normally that you have the top is the coldest part, and then it gets warmer when it gets further down. And if we then get a warmer climate, we would expect that the plants would move further up. So therefore we have this project that is a very long-term project where we are studying the vegetation to see if plant species are moving up.
And the work that we're doing today primarily focuses on the very top of the mountains, doesn't it? Just the top 10 metres, was it?
Yeah. So this is like a big international project where they have collected or picked some tops all over the world, and then they have different teams in different countries that are looking at the tops in their own country, so we can look at the tops. I think from the beginning the idea was that species could be pushed off the top if the climate is changing, so that there will be species that are growing on the very top that are adapted to growing there and don't have any competing species there, and then the thought was that if it's getting warmer there would not be room for them any longer. But I think that what they had seen so far in the project is that there are species moving up, but there are not any species that are being outcompeted there. They are just they are staying there, but there are other species coming in.
So they're learning to coexist.
Learning to coexist or delayed response, perhaps. They are not outcompeted yet. They are just being a thermophilization, I think we are calling it, when it's getting warmer and the whole community is consisting of more and more warmer adapted species.
Okay, great. Mm-hmm. And Peter, we've driven 20 minutes west of Abisko. We've climbed up your nearest mountain. Tell me what we're actually doing today.
So today we will be surveying plants on 4 different sides of the summit. So we establish plots on the north, east, west and south side. And at each of those wind directions we establish 1 square meter plots where we simply record the presence of all plant species, lichens and vascular plants and mosses that we see. So.
And there's a string running around the mountain as well. Tell me what that's for.
Yeah, so we, in addition to those 1 square meter plots, we also survey the entire summit. So we have 2 sections of the summit, one from starting at the summit and then going 5 elevational meters lower, and then a second summit area section where we go 10 meters down. And so in each of those 4 wind directions we again record the presence and absence of all species, plant species and lichens that we see.
And you've been running this project for several years, haven't you? Is this the 4th time that you've been surveying these plots?
Yeah, but we didn't join the first survey, so the first time these particular 4 mountains around Abisko have been surveyed was in 2001, and that has been done by another team. Then these surveys have been repeated in 2008, again by another team. But then a few years ago we took over the coordination of these summits, and so we have been planning these surveys for I think 2 years now. So to prepare for the fieldwork and to get the old data and get the coordinates and everything in place. But we are also surveying another national park in Scandinavia, in Norway. So there we have exactly the same experimental setup of 4 summits at 4 different elevations and then 4 wind directions and so on. And so those mountains we have been surveying also in 2001, 2008 and 2015.
Great. So you've got nearly 20 years worth of data if you add it all up. Is 20 years long enough to start seeing the changes of climate change having effect, or?
Yes, the longer the better, of course, but you have to start at some point. And from the analyses or from the data that we have analyzed in Norway, we really see that on the 2 lowest summits, the species are really changing, even over at that place over a period of 15 years. Wow. And so we see that at the 2 lowest summits, there are really some low elevation species that are warmth loving, are coming in the community. Whereas, of course, at the highest summit, which in Norway is almost 2,000 meters, we don't see any changes yet at this moment.
Not yet.
No.
So would you say that the lower summits are kind of a window into the future then, perhaps what might happen in the higher summits?
Yeah, that's the idea behind the project. So, yes.
And do you do this at the same time every year? Does seasonality affect your plots, do you think?
No, we are doing it in July in the different years, but we are not having many studies in each year, or we are not going out several times in each year. We just go once to the top. But I don't think it matters too much when you have alpine vegetation, because it's a short season and you see most of it when you are coming there. If you had been on lower latitudes like in Belgium or Denmark, you would have perhaps, or Britain, you would have spring flowers and later flowers, but here you basically see it all.
You have one season, you have the short summer, and that's when everything is.
That's where,
okay.
yeah.
I see. Great, and what job have you got for me today?
You are going to record all the species names.
Yeah.
Okay.
That's the fun, or the most fun part of our our work, isn't it?
Yeah, I'll point at things and ask you what they are. So we've just made our way over the ridge into a slightly windier part of the mountain. And the setup here for the sampling is the team have got a big grid of 9 squares in a bright yellow tape. And each of these squares is 1 metre by 1 metre. And then on top of those squares, they've got a grid marking out 10 centimetre squares. So Brenda, we've made our way to the plot and we're hunched over the ground. Tell me what you're doing right now.
Right now I'm looking simply at trying to find all the species that we have in the plot. So first we make like a species list of the plot, and afterwards we will put this frame so we can measure the cover of each of the species, and we can do this pinpointing where you are putting down pins and looking which species are hit how many times in each plot.
Ah, I see. Okay.
So
that's one.
Yeah, so these plots are, I think they are very nice. There are a lot of species here, a lot of mussels. There's, yeah.
So do you know all of these species by name now, by sight, or do you still have to check them?
I still have to check some of them, especially the mosses and the lichens. We have a lot of mosses and lichens here.
Yeah.
But there are also some of the species that are quite common and well known to us. You see the dryas here.
Okay, yeah.
That's it's a very cool species. It's when it gets out its flowers, it's turning the flowers towards the sun during the day, which is nice, like a parable.
Pretty, yeah.
Yeah.
So we've counted all of the different species that we can find in the plot, and Hanne, your next job is to estimate percentage cover of each of the species in the plot. How do you go about doing that?
Yes, to estimate the percentage cover of the different plant species, we mostly use this grid consisting of several small squares, and each of these squares represent 1% of the plot. Mm-hmm. So if a plant species is covering like one of these squares, then it's 1%. Then it's covering 1% of the plot, and if it's half of those small squares, then it's 0.5%. And in this way we can see whether a plant species is very dominant or if it's rare in the plot. And that may be of importance because this may change from year to year, mm-hmm. and this is like a long-term project. So it's important to see the relative dominance of those species, not only what species we see, but only how abundant they are in the plot. Yeah.
Brilliant.
Yeah.
Okay. Talk to me about what we're doing here.
So now we're lowering a pin on our grid, and we write down all the species that we touch with the pin. And so the more pins or the more plants you touch of a particular species, of course, the more common it is. So we do this at 100 points spread across our 1 meter square.
Wow. It's going to be a long day.
And this is the most fun part.
Good.
Carex rupestris.
Yes.
Drias.
Yes.
Drias.
Yes.
Bare soil.
Okay.
Cassiope.
Yes.
Carex.
What carex?
Rupestris.
Okay.
Rupestris.
Yes.
Litter.
Okay.
Øystein, can you just tell us which mosses are there together with Hanne?
I mean, I can't tell them apart anyway, but mosses and lichens, even to the experts, can be sometimes quite hard to identify. So we've had to bring in someone from the other side of the mountain to help us identify these.
This one, it's like the red stamen, isn't it?
This looks to me like Hylocomium splendens.
You think?
Is that Itachium also?
Yeah.
Yeah.
They are
Okay.
both here, I think.
Okay.
This is Pleurosium schreberi.
Okay. Because they may grow together sometimes.
Yeah.
So Hanne, we've finished everything we're doing with our smaller plots up on the mountainside. We've come down a few metres. There's white string leading a path for us. This is a transect, am I right?
Yes, you're correct. Now we're going to do a transect. And the reason why we're doing this is that the small plots that we already have, it's impossible that they contain all the species that actually exist here on the summit. So by doing these transects, we will most likely encounter new species that we can include in our dataset. So that will be more realistic, and we will get a better insight or better idea of what species actually exist here in this area.
Great, so we're just walking along them basically and recording everything that we see.
Yeah, we're walking in straight lines, and then if we encounter a species, we have to identify that and include it in our forms. Yes, that's correct.
Brilliant, right, should we give it a go?
Yes, let's try. Yeah. So here we already encounter Betula pubescens and also some Dryas octopetala. So I'm going to record that on the form.
Great, so we finished surveying our plots for today. Tell me, why is it important for us to be looking at plots on kind of north, south and different facing slopes?
That's because that we have a lot of variation in the mountains. So, you have the overall climate of a place, but then you have also the microclimate. And when you have the microclimate, you are going down to the ground surface, and there it depends very much on the slope and on which direction it's facing. So if you have a north-facing slope, then normally that would be cooler than a south-facing slope, because on the south-facing slope you of course have more sun during the mid of the day. So therefore we are in these different areas, in the different cardinal directions.
And the growing season up here is quite short, isn't it? Because you've got to kind of wait for your gap in snow in the summer up here in the Arctic.
Exactly. And that is actually also another way that the topography is very important. So if you have depressions, you will have a lot of snow that is caught there during the winter. And if you have like a ridge, the snow will be blown off. And then, of course, when it starts melting, there's less snow on the ridge to melt off. And in the depression it will take much longer time. So therefore what you also see in the mountain is not only the south-north things, it's also about how the landscape is shaped and how much snow there is, because the earlier the snow melts, the longer growing season you will have. And if you have an area with a lot of water inflow as well, you will also have a more humid climate. So there's a lot of variation in the vegetation here.
Great, and do you think there's anything that we can do to protect our alpine species?
I think that's a more difficult one because first of all I think actually that the alpine species, there are not very many rare species here. If you go to the Alps in Central Europe, they have a lot of rare species, but up here, this was covered by ice 10,000 years ago. So the species that actually managed to come back to this area, they are quite common and they are very widespread. So it's not a lot of rare species that are here, but there are of course other effects, and then you go into this climate change business. So I think that we have this open landscape, and it's very much driven by the nature and the climate itself, not so much by humans up here. There's of course a bit of reindeer herding, yes. And that is affecting the species composition and
Really, what is it that the reindeer favour?
But they are trampling, and they are disturbing the soils. You have also moose that are browsing. So if there is a lot of grazing, browsing activities, then that will also keep the tree lines down and the growth of the tree down. So that's something that will give more alpine vegetation. If you go to Norway, they have a lot of sheep. Yes. So that's also keeping the tree line down. So sometimes when we are discussing climate, it's a little bit difficult to know if it's actually less grazing that is causing the tree line to move up, or if it's the climate itself. So but we don't have any sheep here. So
I just wanted to add that I'm coming from Belgium and Bente originally from Denmark, and their conservation of nature and forests is looked at very differently, because many of the very common species here are super rare in Belgium, or several of the common species here like juniper and some of these grouse species, and in Belgium we have national parks and nature reserves entirely devoted to the conservation of those species that are super common here. So
in Denmark we have very few orchids, and very limited distribution. And I don't know if you noticed, but when we walked up here, we were passing a lot of different orchids. It's so nice.
Yeah, they're so beautiful.
So, yeah.
I've spotted quite a few when I've been up here.
Mm.
So Peter, we're not doing this today because we're at the top of the mountain, but one of the other things you work on as well is forests and how the kind of forest canopy can help protect species from increasing in warming.
Yeah. So indeed, many of our research and also Bente's is focused on microclimate, and so here on the mountains, this is mostly driven by topography and the slope and the aspect. But in forests, this is mostly driven by the presence of this thermal insulating layer that trees create. And so we indeed try to assess the effects of this thermally insulating layer on the species that grow on the forest floor, on the processes that take place in the soil and in the shade, because it's not very easy to calculate or to quantify the temperature below the canopies of the trees from the temperatures that we measure in standardized weather stations, because this depends on the density of the canopy, the tree species, the way the canopies are packed above each other. So much of our research that we currently do is focused on this question.
And what have you found?
So we find that in terms of temperature below the canopy, that this can really cause significant deviations of up to 10, 20, sometimes even 30 degrees, depending on the temperature outside. So what we find is for maximum temperatures, which is unsurprising, of course, that the warmer it is, that the more buffering you get. So when it's really hot outside forests, like 30, 35 degrees, that you get a buffering of up to 10 degrees or 20 degrees sometimes. Whereas for minimum temperatures, when it's very cold outside the forest, then it's actually warmer inside or below the canopy.
Well, that's enough for one day. It's time for us to head back down from the summit. My time surveying and trying to get my head around all of these mosses and lichens and alpine plants up here is come to an end, but it is not over for the team. They've still got a few more summits yet to survey while they're based up here in Abisko. And the work that they do is going to add to this global network of data, which is going to help us understand how climate change is causing change in the communities at the top of our mountains. So that's that. Thanks for listening to this episode. I hope you enjoyed it. I always certainly enjoy being able to join researchers who work at the top of mountains because they get by far the best views. Don't forget to hit subscribe so you don't miss any of our upcoming episodes, and please do leave a comment or two to let us know what you think. If you have any questions or you want to get in touch, you can tweet the Climate Impacts Research Centre at Arctic Circ or reach me at Emma Brisdian, or check the show notes for other ways to get in contact. I'll see you soon for another episode of Field Notes.